Hi everyone, welcome to the third part of this series. In this video, we will see how we can process and enrich data in Choreo by collecting data from multiple systems. So in the previous two videos, we saw how we can get data from external systems, in our use case from shopping outlets via REST API, and publish those into a Kafka cluster. Now we have our raw data in the Kafka cluster. Now we want to fetch that data. And for each item in the shopping bill, we want to get additional data by customer relationship management system, as well as from the product catalog. And we want to enrich those data and send the enriched data into the Kafka cluster. So if we go into details about what we are going to do here, the sales bill that we receive from shopping outlets will look something like this. So it has the bill ID, customer ID, and the timestamp. And then we have the list of items that the customer has purchased. And for each item, we have the product ID and the quantity. So this is what we get. Now we fetch that from the Kafka cluster, and then we want to enrich that and build a message like this one. So here what we have done is that for each item, so in this case, we are looking at this second item, P56. Now we want to get the product details for that item. So this data is fetched from a MySQL database where we store product data. And there we can give the product ID and get the unit price and the category of that product. So with that data, we have to build this part of the message. Then we also need to get additional information about the customer, in this case C51. So we get that from the CRM system. So there we get the age of the customer as well as the city. So with that data, we build this part of the message. Then we have the timestamp as a string. We want to format it like this. We want to separate it out to year, month, day, and hour. Then we have all this data. Then we have to complete this message by adding the quantity and then calculating the total. So here we calculate the total by multiplying the unit price of the product by the quantity, and we have to include the total field using that. So once we build this message, we have to send that again to a separate topic in the Kafka cluster. So this is what we are going to do in this demo. Now let's go to the Choreo home screen and build this scenario. So this is my Choreo homepage. Now I am going to build a new component for this part. So here we want to poll messages from the Kafka topic. Therefore, I am just going to build a manual triggering task. So let's call it data processing module. So now we create the component. Now the component is created. Now you want to edit this code and build our logic. First, we need to add a Kafka connector to connect to the Kafka cluster and poll messages. So let's add a connector. So in this case, we are adding Kafka consumer, which can poll from the Kafka cluster. So we can give any name for this. Then our bootstrap service, this one. Then we also have to configure the topic that you want to poll from. Topic is sales data. So this is the same topic that we sent the billing message in our previous video. Now we are done configuring the Kafka connector. We can save the connection. Now we need to add a loop to poll this connector. So let's use a while loop. So we give true here so that it will poll indefinitely. Now within the loop, we call this connector. we want to call the poll method. You can give any timeout and you have to give a name for the response variable. So let's name that as build data. Okay. Now within the loop, we are polling this Kafka cluster. Then we want to process this message. Also, we don't want to exit this loop if there's a error in one of these messages, because there can be erroneous messages sometimes, and we just want to ignore those and process the rest of the messages. So let's create a function to do the actual processing part. So we can name the function as process billing event, and we are giving the message that we get from the Kafka cluster as the parameter for this function. So what we get from the Kafka broker polling is an array of messages of type consumer record. Let's name that as records. And our return type is an error, which is optional. Now we defined our processing method. Now we can call that method inside this loop. So the return type of that function is error. So let's name that as just P, and our expression is the function invocation. For this, we can give the billing data variable. Okay, that's it. Now what we have to do is to fill the logic of this process billing event function. Now we want to process each record of this consumer record or the bill data array separately. So we are using for each loop here. So type is Kafka consumer record. And we can name that as record. And our expression is records. Now we are done. So now within this loop, that means for each sales event, we want to do the processing and build the message that we want. Now we want to define a data structure or a record to hold the input message. Now we know that the input message is of this format. So we can just copy this sample JSON and build a record according to that structure. So that is a very nice feature in Choreo. So without defining the data type manually, you can just copy a sample message and go here and create a new record from that message. So let's name this record first. So let's name that as build data. And here we can simply import the JSON. And it will automatically create the structure for our message. Now we have an array of messages that we got from the Kafka broker. Now for each of those messages, we want to convert that to this record type. Now in Choreo, we can do our editing in the graphical view as well as in the code view. So I'm going to switch to the code view and do this conversion part. So first we have to convert this message to an string. So I'm defining a string to hold this message. Then I'm converting the byte values that we get from Kafka to a string. This can return an error as well, so I'm just using the check clause here to check for errors. Then I want to convert this to a JSON first. So I will use the string reader module from the IO package for that. Then I can convert this to a JSON. Check for errors here as well. Then I can simply convert this to our required data structure, which is this one, bill data record. Now we also have to convert our timestamp, which is given as a string, to this format. To pass this string to a proper time structure, I'm using the civil module from the time package. Now, as we have converted our bill data to the bill data record type, I can simply access its fields using the dot notation. Then the next step that we have to do is to call the CRM service and get the customer data for this customer. For that, I will switch again to the graphical view and add a connector to connect with that service. So in this case, what I have is a HTTP service. So I'm using a HTTP client. So let's name that as a CRM endpoint. Then our URL is this one. So if I show the CRM service, but just by invoking that using a REST client, so it looks something like this. So we give the customer ID as a path parameter, and when we send the request, it will give customer details such as the age, address, the city, street, and so on. So we included this as the URL. Then we have to give the customer ID as the path parameter. Now we know that we get customer data in this format. So it's easier if we can define a record type to hold that data as well. So let's copy this sample message and create a data structure to hold customer data. Let's name that as customer data. And we can simply import the sample JSON and create the structure. Now we can invoke the CRM endpoint. So our HTTP method is get and path is the customer ID. So we can get that from the bill data record. So let's name the response as customer data. And our type is a type that we just defined, which is the customer data type. Now we got the customer data from the CRM system as well. Then we have to iterate each bill item from this bill and get the product details for each of these products. For that, let's use another for each loop. Now in this case, we know that our product data in the bill contains the product ID, which is a string, and the quantity, which is an integer. So let's define a record for that, holding that. Let's name that as bill item. The now iterable expression is the bill field of our sales bill. Now for each product, we have to invoke this MySQL database and get product details. So if you look at the MySQL database table structure, it looks something like this. It has the product ID, product name, category, and the unit price. Now what we are interested in the category and the unit price of the product ID. So we can take this table structure and prepare our query. First, we need to add a MySQL connector to connect with this database. So let's add a new connector. In this case, it will be MySQL. And I have to give the endpoint name. So let's name that as product DB. Host is this one. Now here, we can either hard code the username and the password here itself, but it is better if we can give that as parameters at the time of deployment, which is good for security purposes. So let's define a configurable parameter, which we can give at the time of deployment. So let's name this as DB user. And for password also, we are including a configurable. We can name that as DB password. And our database is CityMartDB. Port is the default MySQL port. That's it. Now we have defined our database connector. Now we can invoke the database connector with the SQL query that we need and get the product data. So let's invoke action from the product DB connector. Operation is query row because we know that only a single row is there for a particular product ID. So here in the query, we want to query the category and the unit price for the given product ID. So let's write our query here. We can give the product ID as a parameter. So we need to get the product ID from the bill item. So it will be the PID. Now we can name the variable to hold this product data. So let's call that as product data. And we have to give the record type here as well. So we know that it will contain the category and the unit price. So now we define the record itself without declaring that earlier. Now we are done with invoking the MySQL client. Now we have all the information that we need to build this message. So let's create a message for holding this output message as well. So we can copy this sample JSON and create a record to hold the output message. Let's name that as item sale. And we can import the JSON and automatically create the message. Now we can start populating this output message. So here it is easier to do that in the code view because we have many data items to populate. Now we can fill in each field of this item sale. So we have to include a UID here. Now for the product, we can get details from the product data. Product ID you can get from the bill item. Then let's fill in the customer component. For that, we can get data from the customer data, which we get from the CRM system. Then we have to fill the date. So this we can get from the formatted date that we get from the civil package. Then we can add the quantity and the total amount. So the total, we have to multiply the unit price by the quantity. We have to use the bill ID as well. Now we are done populating the output message for each product. Then we have to send this message to the item sales topic in the Kafka cluster. We can use a Kafka connector to send this constructed message to a Kafka queue. So let's create a Kafka connector first. So in this case, we want to send a message. So we will use Kafka producer connector. Then we can give any name for this one. Then our bootstrap service, this one. So now we have created the Kafka connector. Then we can use it inside our loop to send these messages to the Kafka topic. So here our operation is sent and our topic is item sales. Then we have to view the data items here. So in this case, we have to send our item sale data item that we have created in the previous step into the Kafka topic. So let's use it here, item sale. And we have to send that as a byte array. So let's convert that to a byte array. Now we are done with configuring the publishing part. Now we can run this and test it out here itself. So let's run our application. So here you can see that you have to give the database user and the database password when you run the application. So that means we haven't configured them or embedded them into the code itself. Instead, we configured them as configurables. Therefore, we need to provide values for those configurables at the time of executing this code. So let's give our username and password. To test this out, we can send a message to this billing broker topic, which is basically the sales data topic. And then we can subscribe to the item sales topic and see whether the expected output is given by this application. So here I have connected to this Kafka broker via command line. So this is my publisher part, this is my subscriber part. Then I will send a sample message with the expected format to the publisher. Then you should see the output messages in the subscriber. So let's send this message. And you will see that the output appears in the subscriber view. So there, if we format this output, you can see that it contains all the details that we need from the output. It has the formatted date and the product details, which are fetched from the product database. Then it also has the customer details, which are fetched from the CRM system. Then it has the quantity, bill ID, those which are taken from the bill itself. And then it has computed the total value. And that's it for the third part of this video series. So what we have done here is fetch the bill data from the sales data topic and do a processing by fetching customer data from the CRM system and product data from the product catalog, and then send all these process messages to the item sales topic. So if we put this in the context of the overall architecture, in this part, we focused on this area. And in the first video and the second video, we built the data collection API to collect bill data from sales outlets and to insert those into the Kafka cluster. In this part, we fetched those data and did our processing and send that data back to the Kafka cluster. So in the remaining videos, we will see how we can utilize this process data for various business scenarios.